Hello everyone. Today I will discuss about very important chapter in physical chemistry, that is thermodynamics. So in our physical chemistry there are four main chapters. They are chemical thermodynamics, statistical mechanics, quantum mechanics and kinetics, and four are interrelated. So chemical thermodynamics is the studies of macroscopic system, that means observable system. And quantum mechanics is the studies of microscopic system, that means subatomic particle, electron, proton, neutron. And this statistical mechanics can bridge between the macroscopic system and microscopic system. And kinetics is the study of the rate, either a macroscopic system and microscopic system. So these four chapters are interrelated. So today I will give the introduction of thermodynamics and give the terminology used in thermodynamics. Okay. So if I split the word thermodynamics as thermo plus dynamics. So thermo means you can say heat energy and dynamics means motion. So basically thermodynamics is the study of motion of heat. Okay. So thermodynamics has four different laws. So first law tells us the conservation of energy. So first law of thermodynamics tells us conservation of energy. So energy neither be created nor be destroyed. It can form one form to another form. Second law of thermodynamics tells us push a limit of conversion of energy. Push a limit conversion of energy. That means either energy can transfer to one form to another form or not. Who will decide? Second law of thermodynamics. Okay. So third law of thermodynamics tells us it provides the method to determine the exact value of thermodynamics properties. Basically, it provides the method to determine the thermodynamic property, that is entropy. So what is entropy? I will tell later. So it is a thermodynamical property. So entropy is denoted as S. Fourth law, or you can say zeroth law of thermodynamics, zeroth law of thermodynamics tells us define the temperature and it provides how to measure the temperature. So zeroth law provides us what it says? It says define the temperature. What is temperature? Who said this? Zeroth law of thermodynamics. And it provides how to measure the temperature by thermometer. These are the fourth law of thermodynamics. I will discuss one by one. So now I will discuss the term which broadly used in thermodynamics. Okay. So let's start. So first term is system and surrounding. So before going to thermodynamics main course, you have to know what is system, what is surrounding, what is universe. Okay. So first terminology is system and surrounding. System and surrounding. So system, it is a part of universe. System is a part of universe selected for thermodynamical studies and which separated by a definite boundary. Okay. So it is a part of universe selected for a thermodynamical studies which separated by a definite boundary. Okay. So now this is system. System means we will study the thermodynamical property in this boundary. Okay. And the rest part is called surrounding. Surroundings. Okay. So you can say, what is universe? Universe is system plus surrounding is equal to universe. So this is system where we can study the thermodynamical property and which is separated by a definite boundary. This is what? Definite boundary. So this is a definite boundary. So we will study the thermodynamical property inside the boundary. So this is called system. And rest of the part called surrounding. So universe is the system, this system, and surrounding. This is called universe. Right? And this boundary where we can study the thermodynamical property can be real or imaginary. It may be real or imaginary, does not matter. But the study of thermodynamical property should be inside the definite boundary, and that is called system. Right? And rest of the part is called surrounding. So system plus surrounding is called universe. Whole system plus surrounding is called universe. Right? So system can be different types. So generally system you can divide it into three types. First one is the open system. Open system. This first one, or you can write like A. open system. For example, you put a beaker and fill it by water. This is water. You take a beaker and put inside the water, and you are heated this water by a Bunsen burner. Okay. So water means, water you can consider as a mass. You heating the water by using Bunsen burner, that means you are giving energy. What is the energy? Heat energy. Right. That means, so you can say this is a system. And this is the surroundings. So what is open system? Open system, mass and energy. Heat is energy. Heat is a form of energy. That means mass and energy can be transferred from surrounding as well as system. That means you can add water to the system. You can add water in the system. That means mass can be transferred from the surrounding. This is surroundings and this is the system. System has a definite boundary. That means beaker. Beaker is a boundary. Okay. This is open system. That means mass and energy. What is the energy? Heat energy. Heat energy is coming from surrounding. This is, where is the Bunsen burner? Bunsen burner present in the surroundings. What is the system? System is the only water. So water, that means the mass. You can add water to the system, and energy you can provide the energy, that means heat energy. So mass and energy both are transferable from surrounding to system or system to surrounding. You can take out water from the system, that means mass can be transferred from the system to the surroundings. That means heat, energy and water can be transferred either system to surroundings or surrounding to system. That there is no limit. Mass or energy can be transferred from either system to surroundings and surrounding to system. That means both are allowed. This is called open system. Okay. Second is the closed system. Second number is the closed system. Suppose you put a water in a conical and you close the mouth of the water. Here is the water and you heat the conical. If you close the mouth of the conical, that means you cannot add water more. That means mass transfer is not allowed. But if you add heat, heat can be transferable from surrounding to the system. That means the closed system, it is called closed system. Closed system. So in closed system, mass is not allowed to transfer, but energy is allowed to transfer. So what is the difference between open system and closed system? In open system, there is no limitation for transfer mass as well as energy. But in the closed system, only energy can be transferred from surrounding to system or system to surrounding, but mass is not allowed to transfer neither system to surroundings nor surrounding to system. This is the main difference. But both case energy is allowed transfer from either system to surrounding, surrounding to system. Okay. Third one is isolated system. Isolated system. So isolated system is wrapped with a insulator wall. This is the insulator. What is insulator? It is a material where energy is not enter to the system. So here is the system and this is the surroundings. So in the isolated system there is a restriction. Neither heat nor mass can be transferred from surrounding to system or system to surrounding. That means isolated. Mass and energy cannot be transferred either surrounding to system and system to surroundings. So remember, open system, mass and energy can be transferred. Closed system, only energy is allowed to transfer, but mass is not allowed to transfer. Isolated system, mass and energy both are not allowed. Mass and energy both are not allowed. Right. Next is the properties of the system. Next terminology is the properties of the system. Properties of system. So properties of system is two types. Properties of system is classified as extensive properties, and second is intensive property. So what is the extensive property? The property depends on the amount of the material, right? The property depends on amount of the material, that is called extensive properties. The property which are not depends on the amount of the material, that is called intensive property. So what are the example of extensive property? That is volume. If you add water more and more, that means the volume of water is increasing. That means volume is a extensive property. Volume depends on the material, the amount of material, right? So volume is the extensive property. Heat capacity is also the extensive property. Internal energy denoted by capital U is also the extensive property. It is depends upon the mass of the substance. Then enthalpy. Enthalpy is a thermodynamical property. I will discuss later what is enthalpy. It is denoted by capital H. Then work function. Also the extensive property. Free energy denoted by capital G, also extensive property. Mass, of course mass is a extensive property, etc. These property are the depends upon the amount of materials, right? These are called extensive property. What is the example of intensive property? The property does not depends. The property does not depend the amount of materials. That is called the intensive property. That means density, denoted by rho. Density of water. If you take 1 kg of water, density, and 100 kilo of water. So density are always same. That means density does not depend upon the amount of the materials. That is called intensive property. Okay. So density, another is the temperature. Temperature T, it is also intensive property. Pressure, intensive property. Refractive index, is the intensive property. Viscosity, specific heat, boiling point. What is the boiling point of water? 100 degrees Celsius. If you take 5 gram of water, the boiling point remains same, 100 degrees Celsius. If you take 5 kilo of water, the boiling point is 100 degrees Celsius. Always same. It does not depend the amount of materials. Again, freezing point, surface tension, etc. These all are the intensive property. So extensive properties depends upon the amount of the materials, and intensive properties does not depend the amount of the material. Okay, is it clear? What is the extensive properties and intensive property, right? Okay, next is state of a system. Next terminology is a state of a system. State of a system, number 3. State of a system. The state of a system, it is defined, by state variables. So what are the state variables? State variables are temperature, pressure, volume and N. This is mole number. Okay, so these four are the state variables. For closed system, I already discussed what is the closed system. That means mass cannot be converted from surrounding to system, okay, and system to surroundings, cannot be transferred, right? For the closed system, mole number is fixed. So now state variables are temperature, pressure and volume. Okay. So this temperature, pressure and volume, among them two are independently variable and other one is dependent variable. That means if you take temperature and pressure varies and the other state variables is temperature, pressure, another is the V. V will automatically vary. Okay, or you can say temperature, volume, if you change of a system, automatically pressure will be changed. Or you can say pressure, volume, if you change pressure, volume, then these two are the independent variables. If you change these two independent variables, the third one is automatically changed. So here dependent variable, who is that dependent variables here? V. Here pressure, here temperature. If you take a equation, PV is equal to nRT. It is the ideal gas equation. For 1 mole gas, this PV equal to RT. R is the universal gas constant. If you remove this R, you can say PV versus T. So if you change P and V independently, T automatically changed. So these are the state variables. So state variables of an open system is temperature, pressure, volume and mole number. For the closed system, mole number is fixed, that means N is fixed. The state variables become 3, temperature, pressure and volume. If you change any two independent variables, the third one automatically change, right? Next term is path of a system. Path of a system. So what is this? It is a sequence of, what is the path? It is the sequence of path. Sequence of intermediate step arranged in order. From initial to final state. So what is path? Path is a sequence of intermediate steps of a system arranged in a order from initial to final state. Suppose it is a PV diagram. So here is the initial state, that is P1, V1, and this is the final stage, and this is the point is P2, V2. So y-axis P and x-axis is V. So this system, this is the initial stage and this is the final stage. So either this initial stage to the final stage through this path, you can say this is path 1. Okay, and another way, this initial state come to the final stage through this path. This is called path 2. So initial stage to the final stage, either it go through path 1, this direction, or this process. What is this? This is the sequence of intermediate step. This is a sequence of intermediate step, either path 1, this path, or it form the final stage through path 2. Okay. So path is the sequence of intermediate step of a system arranged in order from initial stage to final stage. Right? Okay, so this is path, means this is number 4th. Okay, this is number 4th. Next is the process. Next is the process. Fifth is the process. So process is the method of operation. Process is method of operation by which the system changes its state. So what is process? Process is the method of operation by which the system changes its state. So there are several processes. Okay, so first one is the cyclic process. Cyclic process. So what is cyclic process? Cyclic process is after series of operation, changes the system come back to its original state. Suppose, if you remember, I draw again, this is the PV diagram. This is the initial stage, that means P1, V1, this point. And this is the final stage, P2, V2. So cyclic process, this initial stage is come to the final stage like this direction, and final stage go back to its initial stage. Okay, you can consider a cylinder. It is a cylinder. It is filled with an ideal gas, and this cylinder is merged with or fitted one frictionless, weightless, movable piston. Okay, so this is the initial stage. It is filled with an ideal gas, right? So this initial stage, you can say this is P1, V1. If the piston go downside like this way, so this is the final stage, this is the initial stage P1, V1, and this is the final stage of the piston. So you can say this is P2, V2. So you just correlate with these two graphs. So this is the initial stage. Okay. So here is the initial stage P1, V1. If you increase the pressure, then volume will be decreases. So this is the initial stage and this is the final stage. If you remove the force, what happens? This piston will go back to this initial stage. So from this the initial stage come to the final stage. And again, if you remove the pressure, then this piston will go back to this initial state. So this process is called cyclic process. Okay. After a series of operations, the change of a system come back to its original state. Right. So this is called a cyclic process. Number B is the adiabatic process. Adiabatic process. So what is adiabatic process? In adiabatic process, the main thing is heat exchange is not allowed. Heat exchange is not allowed. What to have? System to surrounding not allowed. Heat exchange is not allowed in the adiabatic system, right? But when heat exchange is not allowed, then temperature can vary. So in adiabatic system, heat exchange is not allowed from either system to surrounding and surrounding to system. Only temperature can vary. Okay. So this system, in such system called adiabatic system. Number C is isothermal process. Isothermal process. Isothermal. Iso means fixed. Thermal means temperature. It is a such kind of process where the temperature remains fixed. Right? Heat can be transferred. Heat exchange. Heat exchange is allowed. So isothermal process is such kind of process where the temperature remains fixed. So temperature remains fixed, but heat can be transferred from surrounding to system and system to surrounding, but temperature remains fixed. Adiabatic system, temperature can vary, but heat cannot be exchanged. That is adiabatic. Isothermal means the temperature remains fixed, but heat can exchange. Okay. Next is isobaric process. Isobaric process. Isobar or isobaric process. Iso means fixed. What is fixed? Bar means pressure. Bar is the unit of pressure. That means such a system where pressure is constant. Such a process where pressure is constant. Okay. Volume can be changed. Maybe temperature can be changed, but pressure is constant. That is called isobaric process. Next is isochoric process. So in isochoric process, such kind of process where volume is fixed or constant. So such process, volume cannot be changed in this whole process. That is called isochoric process. Isobaric process means pressure is fixed. Isochoric process means the volume is fixed. Isothermal process means temperature is fixed. Adiabatic process means heat cannot be changed. Right? Next is reversible process. Reversible process. Reversible process. It is a kind of process where the driving force and opposing force are infinitesimally small. That means you just consider a cylinder which filled with an gas and it is fixed with a piston. Okay. So driving force. If you put a pressure on this piston will come this direction. Again it comes this direction. If you remove the pressure, it will go its initial stage. That means the driving force and opposing force are very small. If you release the driving force, this opposing force go opposite force operating on the piston and the system will go its initial stage. So this is called reversible process. Okay. And another, the last one is irreversible process. Irreversible process. When the driving force and opposing force are significantly different. That means such a system, the driving force and opposing force are very much different. That means significantly different. That means the piston, the earlier example, the piston cannot be go the initial stage. So reversible process, the driving force and opposing force are very small difference. Okay, but irreversible process, the driving force and opposing force are significantly different. For this, the irreversible process, the system cannot go the initial stage.